Welcome students. We now come to our portion of concept of dimensional homogeneity. Now what we actually mean by homogeneity, I hope you understand that it is basically that if I write an equation, say I am writing an equation something like this, V is equal to U plus AT. Now whenever I write any kind of physical equation, it is bound to have same dimensional quantities of all the values that I have in the equation. Well, let us first check this, whether it is true or not. So this is velocity. Velocity, as you all know, is L t to the power minus 1. So this is U, again a velocity. So this is L t to the power minus 1. Now here we have a product of acceleration times time. So acceleration, as you know, is L t to the power minus 2 into t. So that happens to be L t to the power minus 1. So that shows our case that in every equation that we write, all the quantities are having same dimensional value. So this is what we call dimensional homogeneity. Well, dimensional homogeneity can be checked for any equation, and I will do so for the kinematical equations that we have in physics. So we've already done it for V is equal to U plus Ft. Now I am going to write it for S is equal to Ut plus half At square. Now when I take this particular equation, I have to remember that this quantity is a dimensional constant which I should not consider while taking the homogeneity. So S is simply having a dimension of L, and velocity times time, I hope you have already got it in your mind. So it is del t minus 1 into t, which reduces to simply L. And again I have here A into t square. So it is basically the acceleration into the square of time. So that is again L. So you can see that all the quantities have same dimension of what? That of length. Now I check it for V square is equal to U square plus 2A into S. Now again I should remember that this 2 is of no use for me. So I have V square, so that is L t minus 1 square of which gives me L square t minus 2. Same for U, I have L t minus 1 to the power square. So it is L square t minus 2. And what about A into S? Well, that is L t minus 2 into L. So that is the same value, L t minus 2, which can be taken as L t minus 1 square. So again you can check that all these quantities are having same dimension. So as you can see in the equations of kinematics that all the equations are having same dimensions. Similarly, if I calculate for this particular equation of SNth, that is the distance traveled in nth second, then I have a problem rising here. Well, let us deal with the problem and check out whether this equation is dimensionally correct or not. Well, if you consider the right hand side first instead of left hand that we were doing previously. So the value of velocity is Lt minus 1. Now n stands for time here. These two, this one, these two have no significance whatsoever. Why? Because they're dimensionless constants. So you have a quantity of A, which is your acceleration, and n, which is your time. So now what we have is Lt minus 2 into t. So you see I have a dimension of Lt minus 1. So if I now come to the left hand side of the equation, I can see it is SNth, mind you. So it is simply not L. There is a time involved here. So it shows that what is the distance traveled by the particle during this time. So this dimension should have a dimension of velocity, not simply that of length. So this equation is dimensionally correct as far as the fact goes that this particular quantity have a dimension of velocity. But if this, you consider this to be a displacement, then I am sorry, this equation do not stand correct dimensionally. But you know, in physics we cannot write an equation unless and until it is dimensionally correct. So when I put this equation, I should know that SNth is nothing but having a displacement and time factor associated with it. So it is basically the dimension of velocity. Now I will check for more applications on homogeneity. Say in that case you are given an equation like this: f is equal to at plus bt square. Now when I have an equation like this, I know that all these two quantities should have the same dimension as that of the force. So what is the dimension of force? Well, we know it is mass times acceleration. So it is mlt minus 2. That should be equal to a into time. So a happens to be m, l and t minus 3. Why minus 3? Because it goes there and it gets, oh no, it gets not minus 1, it's minus 1. Why minus 1? Because it comes there, t comes there, you see. If t comes there and then it goes up, oh no, it's minus 3. So I'm just trying to confuse you here. Be careful about the operation here. Be careful about the operation here. I will repeat it. You see, it is mlt minus 2. This is a very common mistake that people do. They write it straight away, mlt minus 1. Now, actually what it should be is mlt minus 2 by t. So when t goes up, the sign comes to as minus, so it is minus 3. So don't get confused if people tell you, oh, why you are writing minus 3, it should be minus 1. Then you should make him understand like this, that why it is minus 3. Well, what about b? Same thing should apply, and let us apply the same thing here again. So it is mlt minus 2, which is equal to b times t square. So now I will write straight away mlt minus 4. So this is one kind of case that we have. Now what is the second case that we can have here? Well, we have a velocity. Say for example it is given like this: at plus b c plus t. So this is what we have for an equation, and you are asked to find the value of a, b and c. Well, the first part is quite easy, as you can see from here, that the velocity dimension lt minus 1 should be equal to that of a into time t. So now be careful, what is a? A is lt minus 2. So don't try to hurry and make it simply L. It is lt minus 2. Now let us come back and concentrate on this part. You see, a very, very important point is the fact you notice that only similar quantities can be dimensionally added. You cannot add length with time, nor can you add a mass with a time. So all you can add with time is simply time. So you see, c should have dimension of time. So the dimension of c is that of time. Now once I have this denominator as time, I know this whole thing should come as lt minus 1, which is actually L by t. So if the whole thing is t, then I can see that b can be nothing else than L. So my final result is the dimension of b is L and the dimension of c is t. I hope you got this point, and I will check out whether you really got this point or not. So let me check out. Well, I give you another equation. I give you something like this. It's already known to you that it is p minus a by v square, and then it is plus minus b is equal to constant. As you all know, this is a famous equation, Van der Waals equation. Now in that case, what is the value of a and what is the value of b? So if you are asked to find the values of a and b, then I should first understand that what is v? Well, v stands for volume here and not for velocity. So I write that this is volume. And p stands for pressure here. Stands for pressure, which you know is force by area. So if I write the dimension of p, that should be same as that of a by v square. Why? Simply because that they are added, and we have already learned that only similar quantities can be added. So what I write the dimension of p as m l t minus 2 divided by L square, and that should be equal to a by v square, means L cube square. So it is a L to the power 6. And then what I do, I cross multiply it here, and I can see with an eventual calculation that this becomes 7. 7 minus 2 is 5. So ultimately A stands for M L to the power, there was an L already here, as you can see here, it is L to the power minus 1 here, and 6 goes there, so it is M L to the power 5 T minus 2. So that is the dimension which stands for A. Now B is very simple, as you can see, the dimension of B should be same as that of volume. So B, volume, is nothing but what? L cube. So B should have dimension of L cube, and A should have dimension of L5 T minus 2. Now in many cases you are asked to find the unit from here. So if you get to the unit, you can see you can break it up like this. I'll write it here itself. It is MLT minus 2, which gives you force, and you multiply it by L to the power 4. So it is Newton for force and meter to the power 4 for the distance. So like this you can carry on doing dimensional analysis over various quantities and also find the unit of those quantities. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.